Welcome to ROAV Perfect classes. In this video, I will discuss about mathematical logic. First topic is propositional logic. Propositional is basically a declarative sentence which has a truth value. It is the simplest form of logic where all the statements are made by proposition. The purpose of using propositional logic is to analyze a statement individually or compositely. Propositional logic is also called Boolean logic because it works on 0 and 1. Propositional can be used symbolic variables like A, B, C, X, Y, Z, P, Q, R, etc. It consists of an object, relation, function, and logical connectives. It can be either true or false, but it cannot be both possible. Object, relations, functions, and logic connectivities. Connectives, which is also known as logical operators. In propositional logic, we use 5 connectives. First is or, second and, third negation or not, fourth implication, if then, fifth is if and only if. Now next point is formula. A proposition formula which is always true, that is known as tautology, means all statements are true, then we can say it is a tautology and it is a valid sentence. A proposition formula which is always false is called contradiction. A proposition formula which has both true and false values is called satisfiable. Now, one example of mathematical logic. We have given principal conjunctive normal form for in square bracket start, in round brackets P or Q, and not P implies not Q square bracket clause. Now I am going to solve this statement. First of all, write again this statement. Now here implies means when we change this implies, then we take on the left side negation. So that's why we write here negation of square bracket in round bracket P or Q and not P. And instead of writing implies symbol, we write or, not Q. When we open this bracket, then multiply negation with all values of inside the bracket. Negation P, due to negation or convert, and not Q, not due to not and convert to or, negation cancel, and P positive. Or not Q, not P and not P or P, we will find P, and not Q or not Q, we will take common not Q, and this is your final answer. Now next question is related to match. On the there are two lists given, first and second. In first list we have given P implies Q, P or Q, P and Q, not P implies Q. And on the right side second list we have given not Q implies not P, P and not Q, not P implies Q, not P or Q. For matching, first of all we have to solve this equation. P implies Q. P implies Q will be solved by this method. We take on the left side value negation, negation P, and instead of writing implies we will write or Q, not P or Q. Now you can match it with the fourth option, P or Q, and P and Q, this is solved equation. And fourth equation, not in bracket P implies Q, not in bracket we write not P or Q, negation negation cancel P, and no, due to not or convert into and, not Q. You can match it with the second option. Now on the right side we will solve first A equation and C equation. When we solve C equation, not P implies Q, we will get P or Q. That will be matched with the second option. Now we solve first A option. A, Q implies not P. Negation of Q or negation P will be written in bracket. When we open bracket, negation negation cancel, and Q due to negation or convert and, negation negation cancel P. Q and P is similar to P and Q. So that's why we can match like this. Now next topic is propositional logic connectives. There are 5 types of connective symbols: and, or, implies, if and only if, that is known as biconditional, and not, that is known as negation symbol, implies, that is known as implication, or disjunction, and conjunction. These are the examples. These are truth table of all these 5 conjunctive symbols. First I am going to explain about negation. This is a negation symbol. This is also not P, not P. If true, P is true, result will be false. If P is false, then result will be true in case of negation. In case of conjunction, we have given 2 conditions, 2 statements. If both statements are true, the result will be true in case of conjunction P and Q. But other cases, whether first equation true or second equation false, whether first equation false, second equation true, or both conditions false, result will be false. And in case of disjunction, if we have given both condition false, then it will be false, otherwise all cases will be true. Whether they are true true, the result true, true false true, false true true. Now in implication, there is a one difference is that false will be when second condition is false. If first condition false, then it will be true. That means both are true, 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 false, 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 true, true, false, false, true. Now next, biconditional. Biconditional, in case biconditional, we will take only both condition true and both condition false, then result will be true, otherwise result will be false in case of biconditional. Now next is a logical equivalence. Logical equivalence. In logical equivalence, first law is commutativity. In this law, when we take P and Q, then if we take on the left side P and Q, that will be equal to Q and P on the right side. If we take P or Q, that will be equal to Q or P. Second is associativity. In case we take 3 conditions, P, Q, R. If we take P and Q in bracket and R outside of bracket, that will be equal to, if we take P outside of bracket and in bracket Q and R, that will be equal. P or Q in bracket or R outside of bracket equal to P or in bracket Q or R, that will be equal. Identity element. If we have given P condition and we have to compare with true, the result will be statement. But if we take one statement or symbol or operator, then we can and compare with true, the result will be true. Fourth is distributive law. In this case, we will be distribute in this method. We have given P and Q or R. We multiply P with Q and write in first bracket P and Q. Then write symbol which is given in bracket, that is OR, outside of this bracket. And in second bracket P multiply R, that means P and R in second bracket. In case OR, P or Q and R, then we P multiply Q, we will write it in first bracket P or Q. When we multiply P with R, then we write P or R in second bracket. And this symbol will be written in between both brackets. This is the distributive law. Now next law is De Morgan's law. In this law, negation of in bracket P and Q, when we open this, then we can write like this: negation P or negation Q. Negation P and negation Q. This is a De Morgan's law. Now next is a double negation elimination. In this law, when we take double negation of any statement, then result will be same statement, means negation of negation, that will be positive. Now next topic is predicate logic. Predicate logic is an expression of one or more variables which is determined on some specific domain. A predicate with variables can be made a proposition by either authorizing a value to the variable, that is known as authorizing. When we give the value to variable for quantification, that is known as quantifying. For example, here we have given XA in bracket A, B, C. Here A plus B plus C, that is equal to 0. This is the value of A plus B plus C. Now next is a quantifier. The variable of a predicate is quantified by quantifier, and there are two types of quantifier. First is for all, second is there exist, and this symbol is also known as existential quantifier. When we write here this symbol and xpx, that means there exists at least one value in the universe of the variable x, that is px is true. In case universal quantifier, we use for all. For all x belongs to A, comma px. We can write it like this. Means there are many ways to write a proposition with a universal quantifier. Px, comma, for all x belong to A. For all x, comma, px. Px is a true for all x belongs to A. Now I am going to discuss about next topic is normal forms. The problem of finding whether a given statement is tautology or contradiction or satisfiable in a finite number of steps, that is known as decision problem. There are two types of normal forms, conjunctive normal forms and disjunctive normal forms. First is a conjunctive normal form. If P and Q both are, there are two statements, then P and Q is a compound statement, and we can write it P and Q. We use here conjunctive symbol. If P and Q are two statements, then P or Q is a compound statement, and we can write it P disjunctive symbol Q. Now next is a rules of inference. First rule of inference, and we have to, before discussion of rules of inference, you have to clear in mind that DNF, disjunctive normal form, is also like union, and conjunctive normal form is also like intersection. Rules of interference. These are the rules of inference. First rule is addition, that is known as disjunctive syllogism. We have given example P, one statement, P or Q statement. When we add them, we get P or Q. On the other example, we have given P or Q, and second statement is given not P. Not P cancel with P, and we find Q is the answer of this disjunctive syllogism. Second example of conjunction or hypothetic syllogism. In this case, P and Q, two statements are given. When we conjunct them, we will write P and Q. Second example, P implies Q and Q implies R. When we solve this equation, not P or Q, not Q and or R, Q and not Q is cancelled, and we find not P or R, and this will be right like this, P implies R. So that's why answer is P implies R in case conjunction. Second example, this is related to constructive dilemma. In case P implies Q and R implies S, we have given first statement and P or R second statement. When we solve this, P implies Q will be convert negation of P or Q, and R implies S convert into negation of R or S. P or R, P cancel with not P and R not R cancel with R. We find result Q or S. This is a constructive dilemma. Next is a P implies Q or P cancel with P, and we find Q is the answer. Modus ponens. Modus ponens. In case modus ponens, we have given example P implies Q, R implies S, not Q, not S. When we solve this equation, we find not P or not R. How? We will solve this equation like this: not P or Q and not R or S. Q cancel with not Q and S cancel with not S, and we find not P or not R. This is your answer of modus ponens, and you can say it is a destructive dilemma. Now next is a modus tollens. In modus tollens, we use this equation P implies Q or not Q. When we solve this equation, we find not P or Q, Q cancel with not Q, and we find not P is the answer. Now next topic is set operations. There are 5 types of set operations: union, intersection, difference, complement, and Cartesian products, that is also known as cross products. First is set union. We use this symbol for union, A union B. All elements of A and B will be taken, means first we take common value, then we remaining value. Here we take example A 1 2 3, B 3 4 5. We take one common, that is 3, and 1 2 3 4 5 also we taken here because it is a union. And in case set intersection, we take only common value, so result will be A intersection B, that is 3 from these two sets. Now next is a set difference. What is a set difference? Set difference means we have to see that A's element must not be in B's element, must not match with B's element. That means those elements which are not in B, that is the answer of A minus B. So here answer is 1 2, because 1 2 is not present in the B's set. Now next is a complement of a set. A set is given 1 2 3, union is in universal set is given 1 2 3 4 5. You can see A's complement will be 4 5, because 1 2 3 is present but 4 5 is not here. So that's why A's complement will be 4 5. Now next is a Cartesian product and cross product. In case Cartesian product or cross product, we will take 2 examples two statements, A is equal to 1, 2, 3, B is equal to A, B, C. When we multiply, then we can first one multiply with all these values of B, all elements of B, 1A, 1B, 1C. Then 2 multiply 2A, 2B, 2C, and then 3, 3A, 3B, 3C. If we take two elements, 1 or 2 or AB, then the result will be 1A, 1B, 2A, 2B. These are the Cartesian's product. Thank you. If you like my video, please like and share my channel with your friends. And don't be forget to subscribe and click on bell icon so that you can get the notification of next coming videos.